Hi everyone. Okay, so we completed the slide set from page 1 through 9. I mean 8. So uh, today's topic is covariance and correlation. Hopefully, we can complete the very basic foundation of regression today. Okay, so covariance. So we have two formulas here, but don't worry about this computational formula because we do not use this formula to do hand calculation or things like that. I mean, we still can go through the hand calculation to understand the underlying ideas of the way how this formula is working. But this computational formula is applied in statistics program, like syntax-based program, for example, data or whenever you use like Excel, yeah, you need this kind of computational formula rather than this conceptual formula, because this can make the machine things easier. The consequence is the same, regardless of whatever you use. Conceptual formula here, this is a covariance formula. So what is covariance? Covariance is association, correlation between two variables, covariance. So yesterday, you know, you have some chunk of dots in a coordinate xy axis coordinate, right? There's a bunch of dots there, right? So one dot has the location that represent one value on the x-axis and one value on the y-axis, right? So we have, for instance, we have 300 dots. That means we have 300 individual data in the scatter plot yesterday, right? So this conceptual formula shows covariance. So I is individual I from 1 through the number of n. So I gave you 300, for instance. So you have to calculate this. If you have 300 individuals, so you have 300 x values, you have 300 y values, right? Of course, we know how to calculate the mean of x. X bar is mean of x. Y bar is mean of y's, right? So each value minus mean times multiplication, and each individual y value minus mean y, okay, multiplication, okay. So you go through this process until you get to 300 value, the individual, right? So you have x1 minus x bar times y1 minus y bar plus this capital letter, Greek letter stands for sum. So what you're doing is x1 minus x bar times y1 minus y bar plus, because this is sum, plus parenthesis x2 minus x bar times y2 minus y bar plus blah 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 until x 300 minus x bar times y 300 minus y bar, the numerator, sum them up, and then divided by n minus 1. So which means 299. Okay, this denominator in the statistics is called degree of freedom. I'm not sure if I have a chance to explain what the meaning of a degree of freedom later, but denominator is a kind of synonym of degree of freedom. Denominator is the same as degree of freedom. Degree of freedom, short language, DF, degree of freedom, is nothing related to the degree of democracy, anything like that. Freedom is here statistically. Because you know, last time I was talking about we do not collect the entire population data. So eventually we go through a inference process, which means how probable the sample statistics can be inferred to the population parameter. So based on your sample statistics, you're gonna guess how the population parameter will be. So that is the ultimate goal, right? So you calculate something, I mean, you estimate something based on sample data, and then whatever values derived from sample data is called statistics. And whether or not we predict the population parameters using sample statistics matters in the future. So if it can be possible, very basic assumption is that the collected data that you use for the sample statistic should be unbiased. Does it make sense? Otherwise, if it is already biased, whatever you estimate from the sample data is not supposed to be used to guess the population parameters will be because it's totally different data, right? Sample is supposed to be a subset, representative subset of the population data, okay? Otherwise, the inference doesn't work. All right, so that's why sample collection is really, really, really important. Anyway, what we remember is this conceptual formula, okay? We don't have to remember computational formula. Conceptual formula is really similar. Conceptual formula of the covariance is really similar to that of variance. What is variance? Variance is a univariate value. When you have only one x, I mean one variable, you know, like 300 dots only on the x-axis, or 300 dots on the only y-axis, whatever it is called, the axis. If there is only one variable, it is a variance. So, you know, how they are varied, how dots are varied on that axis. This is a definition of variance, right? So how can we calculate that? So on the axis, you know, there is a center cut 0, and then minus values and plus values, right? If you just sum them up, you know, because of the 0 and because of the minus value plus value, it's gonna be a 0 if you just sum them up. So in order to avoid that situation, what you wanna do is, in the calculation of variance, you wanna do that, make it squared value, right? So xi minus x bar, things like that. So you make it squared, and then sum them up, and then divided by n minus 1, degree of freedom. Degree of freedom, not just n, okay? Sample statistics use the degree of freedom as n minus 1, not n. Okay, I'm gonna talk about it later, why we have to use n minus 1, not n, later, okay? So when we calculate covariance or variance, we have to use n minus 1 for degree of freedom, not n. Anyway, this is not the time that I can explain them now because too many concepts make you very confused. So, all right, anyway, so when you have only one variable, you have just, xi minus x bar squared. But here we have two variables. We want to know the variable relationships, right? So xi minus x bar times yi minus y bar, like that. Okay, so let's think about it. If it is just univariate, xi minus x bar squared, and then sum them up and divided by n minus 1. That is a variance definition, conceptual formula, right? So you will immediately know that, oh, then the squared scale is squared, not the same as the row scale of x. So the magnitude is different between the squared value and the row scale of x, right? So in order to go back to the row scale from the variance squared value, you need to do, what do? You need to make it what? You have to put on root, right? Square the root. We have to do it root. So then the variance can be converted into the original scale. So you can compare the magnitudes between the variance concept and the row scale of x. Am I right? What do you call it? The squared rooted value. What do you call it? That is called standard deviation. If you don't convert it into that standard deviation, you cannot compare the magnitude between the variance, variability, and the row scale of x. You cannot, because one is squared and the other is just row scale, okay? All right, so here, in general, when the covariance is large, positive number, y tends to be large. When x tends to be large, both are positive. When the covariance is a large, negative number, y tends to be large and positive. When x tends to be large but negative. When the covariance is near 0, there is no clear pattern like this. Positive values tend to be canceled by negative values of the product. Now, covariance can be converted to correlation. Okay? So SXY means the covariance between X and Y. SX means variance. No, not variance, because this does not have a square here. This is standard deviation of X. This is a standard deviation of Y. There is one problem with the covariance. What is it? It is in raw score units, which means if you show covariance between people's weight and the people's intelligence, and then the other covariance between the people's height and the people's intelligence, there will be two different covariances. However, you cannot compare the covariance for the relationship between the weight and the intelligence and the covariance between the height and the intelligence, because all three variables use different units. For instance, weight use pound and height use feet, feet or centimeters. So you can't compare the values, numbers directly, because all three variables use different units, different scales. So this is another story that I was talking about in the previous slides. In the previous slides that I was talking about squared value, which is variance. And then when we convert it into raw scale, we need to make it rooted squared one, right? Which is standard deviation. In this slide, this is a different unit system, not squared or rooted squared one. Anyway, this is about, like, you can't compare the weight and the height directly because they do not have a different unit system. So in order to compare two different unit systems, two different variables, magnitude, how would you do it? You want to make it standardize them to compare them. How? You want to make the covariance to correlation, because correlation is the standardized covariance, okay? So we cannot tell much about whether the covariance is indeed large enough to be important by looking at it. The solution to this problem is the same solution applied in the realm of comparing two means. We standardize the statistic. Here, statistic means covariance by dividing by a measure of a spread of the relevant distributions. Correlation coefficient is defined as, correlation is R, alphabetical letter R. Alphabetical letter R is Pearson correlation between X and Y equals to covariance X and Y divided by the multiplication of standard deviation of X, standard deviation of Y. Because covariance cannot exceed the absolute value of the multiplication of standard deviation of X, standard deviation of Y. The limit of R, absolute value, is 1. So last time I was talking about the range of R, absolute value of a range of R is between 0 and 1. The minimum is 0 and maximum is 1. Therefore, one way to interpret R is as a measure of a degree to which the covariance reaches its maximum possible value. When the two variables covary as much as they possibly could, the correlation coefficient equals 1. Okay. Now, the final topic, regression line is very important. So I'm gonna do this in the next class, okay? Thank you. If you cannot understand, and please repeatedly watch this video. If you still cannot go through it, just email me. Or just leave a message or questions on the YouTube video, okay? Whenever you find out something not sure, indicate the time point of the YouTube video, so then I can easily find that which part you are not sure, okay? Thank you very much. Have a nice day. Bye.